Hey everybody, so today you're going to be reviewing for your Chapter 10 test. What I'm going to do with you really quickly is a Unit 10 summary and quick practice just to try to pull everything together. So you need to know two formulas for arithmetic sequences and series. There is the explicit rule formula, which is just how to write a rule, how to write an equation for the nth term of an arithmetic sequence, which is a sub n equals a sub 1 plus n times 1 times the quantity of d. And then also remember, we want you to put your answer in to look like a line, a linear equation, in slope-intercept forms. So once you do get it, distribute whatever d is and combine like terms, and then write it in the form mx plus b, which would be really mn plus b since we have n instead of x. Okay. All right. My highlight went away. There we go. Woo. Okay. Notice always simplify this formula. We said that. Okay. So now what if you wanted the sum of that sequence, which is called a series if you're adding it all up? You're going to use the sum formula, which is you take the number of terms times the quantity of, you plug in 1 to get the first term. You might have to plug in 0 to get the first term, or 22 to get the first term if it's written in summation notation. But that's just the first term in the series. And then a sub n is the last term in the series, plus, or sorry, those two added, divided by 2. Wow, that was hard for me to say. Okay, so this is all for arithmetic. These two formulas right here, this rule and then this formula for sum, is for arithmetic. So this is if there is a constant increase of like plus 2 plus 2 plus 2 plus 2, or minus 4 minus 4 minus 4 minus 4, so or a constant decrease, right? So, and also this will always be linear. It'll look like an equation of a line. All right, geometric sequence and series, you need to know 4 formulas. I don't know why it says 2 formulas, because there's 3. Okay, so there's 3 there's just like a 4th idea. Okay, so this should not say 2 here, so wrong. Okay, so to write a rule, it's a sub n equals a sub 1 times r to the n minus 1, where r is your ratio, so the multiplier. So what do you multiply by to get the next term? To sum a geometric series, you take the first term times 1 minus whatever r is to the nth power. You want parentheses around that in case r is a fraction or a negative number, divided by 1 minus r. Okay? Now, this is the sum of a series that ends. So like if I want the sum of the first 26 terms, the first 48 terms, that's the formula you use. But what if the series doesn't end? You're going to use a sub 1 divided by 1 minus r. Now you're only using that formula if r is in between negative 1 and 1. So therefore, if r is greater than 1, or r is less than, wow, that doesn't make sense, r is less than negative 1, then the sum has to be either positive infinity or negative infinity. Okay, so if it's less than negative 1, then it's negative infinity. If it's more than positive 1, then it's positive infinity. But this is only for an infinite series. Okay, so for example, I want to make sure you know what formula to use, or can you use a formula, and how should we approach these, okay? So first off, let's go through and say, can I use a formula? Okay, to decide whether or not you can use a formula, you are going to look at the expression next to the sigma, which is this. You're going to look at this, okay? You are going to look at it and see if it's arithmetic, geometric, or neither. If it's arithmetic, you can use the arithmetic sum formula. If it's geometric, you can use the geometric sum formula. If it's neither, you can't use a formula. You have to plug in those values. Okay, so let's look at this first one. This one right here. That is an equation of a line. Therefore, this is arithmetic. So I can use my arithmetic sum formula. So you can look back at the top. We did have students memorize these for the test. If you have them in your brain, that's great, because I know they don't give them to you on the SAT or ACT, and I have seen them there before. But if you don't know them, you're lucky, because you can look at them, right? So the sum of, and then I need to know how many terms there are. So 1 through 27, right? 1 through 27, there's 27 terms. All right, so make sure you're using the arithmetic sum formula, which is n, 27, times the first term plus the 27th term divided by 2. So now I have to find the first term. A sub 1 is equal to 5 times 1 plus 2, which is 7. I just plugged in 1 right here. And then I need to find the 27th term. So I need to plug in 27 right here. 5 times 27 plus 2, 137. Okay, so now I'm ready to get the sum of the first 27 terms of this series. I'm going to put 7 plus 137 in my calculator, hit enter, divided by 2, hit enter, times 27, hit enter, and you get 1,944 is the sum of that series. Okay, all right, let's look at the next one. Is this highlighted in yellow arithmetic, geometric, or neither? It's geometric. Why is it geometric? Because this is an exponential function. There is a variable in the exponent, right? So this is an exponential function. So geometric, and I can use my geometric sum formula. So I want the sum of, how many terms are there? 1 through 23 is 23 terms. All right, now geometric formula is the first term. So I need to know what the first term is. Now remember, this is in the form a times, a sub 1, sorry, times r to the n minus 1. So this is a, 3/2. Times the quantity of 1 minus r. R is 2, right? It's 2 right here. So I have 2 to the nth power, which is 23, divided by 1 minus r, which is 2. Okay, so now only mistakes you can make here is putting in your calculator wrong. So we're going to do some mental math. 1 minus 2 is -1. Now I'm going to do 1 minus parentheses 2, close the parentheses, 20 to the 23rd power, enter, divided by -1, enter, times 3/2, enter. So I get the sum of the geometric series is 12,582,910.5. And my notability froze for the 187 billionth time today. Whew, getting heated. Okay, next one. Look at the highlighted yellow. It says arithmetic, geometric, or neither. So really quickly, if I go like this, it's arithmetic. But because that cube is there, this is neither. This is a cubic function. So I cannot use a formula. This tells me that I have to plug in 3. I have to plug in 4, 5, and 6, see what I get for each one of those, and then add them up. So I'm going to organize here. 3, 4, 5, 6. I'm going to plug in. Why do I always write the last number so close? Who knows? Okay, so I'm going to plug in 3. 2 times 3 is 6. 6 minus 4 is 2. 2 cubed is 8. Plug in 4. 4 times 2 is 8. 8 minus 4 is 4. 4 cubed is 64. Now remember, I'm adding these up. Plug in 5. That's 10 minus 6. 10 minus 4, which is 6. 6 cubed is 216. Which you can use your calculator for all this, remember. Plug in 6. 2 times 6 is 12. Minus 4 is 8. 8 cubed is 512. I'm looking at an answer key. I did not have that memorized. Okay, so now I can add these 4 numbers up, and I'll get my sum. That is 800. Okay, and guess what froze again? I don't remember how many times I said it froze, but I'm sure I said 80 billion something. So 80 billion and 1? Okay. All right, next two. So first off, I'm going to look to see if this is arithmetic, geometric, or neither. I don't know why I didn't highlight like I did on the others. Arithmetic, geometric, or neither. So if you look, both of these are geometric because they both have variables in the exponents. So I say, okay, I'm going to use my geometric sum formula. So I say, okay, the sum of, and then how many terms am I summing? Oh, 1 through infinity. So I'm doing an infinite amount of terms. So now remember, this formula is the first term, which is a sub 1, divided by 1 minus r. Now the only way you're using this formula is if r is in between negative 1 and 1. Is r in between negative 1 and 1? No. R is 3. So that means this formula is just going to keep multiplying by 3 forever and add up all those terms. It's practically impossible here. You can't do it. Not practically impossible. It's impossible. That's infinite. Okay. All right, next one right here. Look, it's very similar, but I switched this 3 and the 1/9. This time r is 1/9, which it is between negative 1 and 1, so you can use the sum formula. So the sum of this infinite series is first term, 3, divided by 1 minus r, which is 1/9. Do not overuse your calculator. Do this first. What's 1 minus 1/9 without a calculator? 8/9. So now you're doing 3 divided by 8/9. If you are going to use your calculator, which I don't suggest, make sure you put the 8/9 in parentheses. Instead, I'm going to say 3 divided by 8/9 is the same thing as 3 times reciprocal, 9 over 8. Put 3 over 1, multiply straight across, that's 27/8. Right? So if you put down a decimal answer that's equivalent to 27/8, it's fine because it doesn't tell you how it wants the answers. Okay. Next thing I want to make sure everyone's okay with is basically knowing how to read this. So it says write the first 5 terms of the sequence. So I know the first term is 3, the second term is 5, and then I need this term, and this term. Okay, so I need my third term. So let's see what the rule says. It says take the previous term, so the second term, which is 5, plus 2 times the one 2 previous. So 2 previous to this is 3. So I get 11. All right, next one. A sub 4, take the previous term. Previous term is 11 plus 2 times 2 previous. Right? Ooh, look at that. So 1, 2. That's 5. So that's 21. A sub 5, the previous term, 21, plus 2 times the one previous to the 21, which is 11. So 21 plus 22 is 43. A little mental math there, right? Okay. All right, so this one right here, I decided not to do two terms of an arithmetic sequence because that's so easy. Because arithmetic's a line, you can write them as points 5, 9, and 10, 2187, and then find the slope, write the equation of the line. Geometric's not as easy. People have always struggled with that more. So arithmetic, look at your notes if you need to look at another one, but it's just, remember, it's linear. Get your 2 ordered pairs, write your points. Slope, plug it back in to write your equation of your line. Geometric, you're going to have to write a system. Okay, so it's geometric. Remember what geometric looks like. A sub n equals a sub 1 times r to the n minus 1. So what I did give you is that your fifth term is 9. Okay, so highlighting here, fifth term, meaning when I plug in 5 here, I get an output of 9. I get this is 9. So I can write one equation so far. 9 equals a sub 1 times r to the n minus 1, 5 minus 1. And then I'm going to change that to 4 because I can do that mental math and make it easier right now. All right, for my second equation, I'm going to do the same thing. I'm going to say this is my output. So 2187 is equal to a sub 1 times r to the, and then once again, this is my input here, 10. So 10 minus 1 power, which is 9. So I'm just going to write 9 instead of writing 10 minus 1. All right, so now I need to solve this system. You're always going to solve these systems by substitution. Elimination is not a possibility. you're always going to start by solving the first equation for a sub 1. So how do I get a sub 1 by itself? Divide by r to the fourth. All right, divide by r to the fourth. Gone. You have a sub 1 is equal to 9 divided by r to the fourth. So now you're going to use the substitution. You're going to substitute this into this equation. So now I have 2187 is equal to 9 over r to the fourth times r to the ninth. Remember, you're going to make this one big fraction right here. You have 9 r's in the numerator, 4 in the denominator, so I can get rid of all 4 in the denominator, and there's 5 left in the numerator. So now I have 2187 is equal to 9 times r to the fifth power. Divide by 9. I get 243 is equal to r to the fifth power. And now I have to fifth root both sides to get rid of the fifth power. So remember, my calculator can fifth root. If you want to know how, I will tell you in words right now. You hit a 5. Okay, then you hit the math button. And you toggle down to, I think it's option number 4, which is x root. Right? And you click that. So now it'll do the fifth root of whatever number you type. So you hit 243. So that's one way. Or remember, to get rid of a fifth power, it's the same thing as the 1/5 power. So you can do 243 to the 1/5 power. And that is 3. All right, so I got this. It's 3, right? But I still need this. So now I have to solve for a sub 1. So I'm going to solve for a sub 1 using this equation right here. So I'm going to do a sub 1 is equal to 9 divided by r, which was 3 to the fourth power. A sub 1 is equal to 9 over 81. And then simplify that fraction, 1/9. So now I can write my rule. A sub n equals a sub 1, 1/9, times r to the n minus 1 power. And I put r because I got a message and I started looking at it. Okay, times r a 1/9 times, where's my r? 3. 3 to the n minus 1 power. Now, you don't need parentheses around that 3, but I like putting them there. Okay, and that's it. So that's just a summary of a few things that we did. I would say the more difficult things that maybe people struggle with. You can go ahead and get started on the review. And then the next video that I'll post will be really quick. It'll just show you how to screencast your test. You are going to end up submitting a PDF of your test, of your work. And then you're also going to submit a screencast of it. So I'm going to, have your screencast open on my iPad, your work open up on my computer, and I'm just going to follow through and make sure that you are explaining it well and that you know how to do the problems, okay? So that video I will post in a couple days. All right, have a great day. Don't forget to do the